Probability, please, ladies and gentlemen. What is probability? Probability is the, anybody? It's the likeliness. Is that what's the word? The likeliness? I don't think so. Actually, the book says likelihood. I'm going to put likely. Go with likelihood. Likelihood, I mean, of something happening. Generally, ladies and gentlemen, we express probability in fraction form. Usually in fraction form. And that's based on this thought process here. So let's say I've got this little line here. Here is 0, and here is 1. If your probability is 0, it will never happen. It is impossible. The probability that today is Tuesday is a big fat 0. It's impossible. If the probability is 1, that's the other side of the spectrum, which would mean that this thing is absolutely positively certain. The probability of today being Monday is a certainty. We know that for sure. The probability that Sam's wearing blue today looks like it's pretty certain to me. All right, and then every fraction in the middle, is something a little bit different here. If you have the fraction 1/2, since it falls exactly in the middle of 0 and 1, it is as likely as not to happen. As likely as not to happen. You flip a coin, the probability should be 1/2 for it to be fair that it's going to be, If it falls then in this range right here, it is unlikely. And if it falls between 1/2 and 1, then it is likely. Now notice if it falls in the unlikely category, it could actually happen. It's just not likely to happen. Same thing over here. Even if your probability is 7/8, which is way over here, there is a small chance that it will not happen. Now, generally speaking, here is the way we do probability. Let's say I've got a spinner. I love spinner. And let's say this is a fair spinner. And we got sections A, B, C, and D. If I ask you the probability of spinning an A, you math people like to shorten that little phrase a little bit. Generally, this is how you would show it on your paper. You put the capital letter P, and then in parentheses, you put what you want. I want the letter A. So this is a short way to say the probability of letter A. And then when you figure out probability is, on the bottom is the total number of outcomes. And on the top are the ones that they have, or the ones that are desired. So if you're looking at this is nothing new to you. The probability of getting an A is, how many different quadrants are there? There's 4. How many of those 4 are A's? 1. So the probability simply is 1/4. Will it happen? Who knows? Is it likely to happen? No. It's really unlikely that you're going to get a 4. But in 4 tries, the odds say, or the outcome, or the probability says 1 in 4 you're going to do. Now, what about, let's roll a dice. You roll your dice, you move your mice, and nobody gets hurt. And you have to have some prior knowledge to this. If I asked you the probability of rolling a 3, what would that probability be? Well, how many sides to a die? 6. How many 3s are there on a die? Just 1. Or what was my probability of, how about this? A number greater than 4. Well, greater than sign, how about that for shortening stuff? Probability of a number greater than 4. How many sides to a dice? 6. How many numbers are greater than 4? 2. And you'd have to reduce that, so it's 1/3. Will you get a 4? Who knows? The probability is 1 in 4. Got that? Good, because I need, oh wait. Did we talk about sample space? Do I see something where sample space is? Oh yes, under this sort, well, I guess blank piece of paper. You have to do that, just because you won't know to look under probability. Sample space. Just simply means where you list all possible outcomes. Sometimes it's easy, sometimes it's not. If I said to give the sample space of rolling a die, you would say this, and by the way, since it's a set of numbers, we put it in this little lovely thing we call a brace. And you just have to list all the combinations of rolling a dice. 1, 2, 3, 4, 5, and 6. That's your sample space. What about the sample space of flipping a coin? What is your sample space? Your sample space would be just a head and a tail. Now look how complicated this gets if I ask you for the sample space of flipping a coin twice. What could happen? Well, sometimes it's good to chart it out and make a little tree diagram, and this is what that would look like. On your first flip, what are your possible outcomes? You could get a head, or you could get a tail. That's your first flip. But if you flip again, on your second flip, off of each one of these, if you flipped a head first, on your second flip, you could also get a head or a tail. If you start off with a head. If you start off with a tail, you could also get a head or a tail. Your sample space is all of those combinations, which means this. I put my little brace. I could flip a head and a head. Head. I could flip a head and a tail. I could flip a tail and a head. And I could flip a tail and a tail. Those are the 4 combinations if you flip a coin. And if I asked you for the probability of a head, you would look at your sample space and say, well, I know there are 4 different combinations. Only one of them is a head, so it's 1/4. What if I asked you this? Let's mess with you a little bit. What about the probability of getting at least one tail? What would be my probability of getting at least one tail if you look at your sample space? There's still 4 different combinations. Whoa. And how many of those do you get at least one tail, Sam? 3 of them. I have at least a tail there, at least a tail there, at least a tail there. 3 out of 4 times if you flip a coin twice, you get at least one tail. I think that's pretty exciting, don't you? Now a blank piece of paper. You just have to do some definitions here. Things that get confused with probability a little bit, and the first one is chance. Chance, boys and girls and ladies and gentlemen, is really the same as probability, except, anybody know except what? Same as probability except in percent form. Exclamation connotation point there. And a good case in point of that is when you listen to the weather forecast, when they give you the forecast for rain, they tell you in percents. They give you the chance of rain. And if your chance of rain is 25%, you know, is it going to rain or isn't it going to rain? Well, you don't know for sure, but it is unlikely to rain because that's the same thing as the fraction 1/4. You know, but they don't give it the probability of rain is 1/4, but the chance of rain is 25%. So it's really the same thing as probability, just we give it in percent form. I don't know why, I just followed this. Then another blank piece of paper, because this one you should know as well. This one will come up on tests and quizzes, so if you're a betting person, which I certainly do not, mostly because I lose all the time. Maybe you've heard the odds. You know, when they talk about football games, Brady, right? Mm-hmm. What are the odds that the Lions are going to win? Pretty likely. No, we normally don't do it like this. We do odds. The odds are a lot like probability and a lot like chance, except you have to write odds. Odds are written as favorable to unfavorable. Which means this. If I asked the odds of picking a girl in 7S class, that means this. You have to know how many girls are in this class. You don't know how many are in your class here. 1, 2, 3, 4, 5, 6, 7 of you. 7 girls. And then you'd have to put 2. How many are not girls? Which I'm guessing there's 17 in your class.
Yeah.
So there must be 10. The odds of you are 7 to 10. Okay. The probability of picking a girl would be, how many girls? 7 out of 17. The chance of picking a girl, you'd have to convert this into percent form, which would be close to what? What's 42%? 6 times 7? Yeah. Is 102. So it'd be close. It'd be close to, it'd be a little less than 42%. So probability are favorable to unfavorable. Percent is in probability is in fraction form, chance is in percent form. What else do we do probability of? Or odds of? The odds of rolling a 3 on a die. Well, how many 3s are there? 1. How many not 3s are there? 5. 1 and 5. 1 to 5 would be your odds. Now, unfortunately, we have to go back one more time on this. We have to go back to the original probability because we have to talk about this. Under probability, we have 2 different types of probability. One of them is theoretical probability, and the other one is experimental. Theoretical probability compared to experimental probability. Theoretical compared to experimental. Are you ready? Take a deep breath. theoretical probability is the mathematical probability, and experimental is what actually happens. I will give you a for example. The theoretical probability of flipping 3 heads in a row is, I'll just give it to you, it is 1/8. It's 1/2 times 1/2 times 1/2. We could do the tree diagram here. The tree diagram would look like this. Here's your 3 flips. Wait, I already did 2 flips somewhere. Where did I do it? Where did I do sample space? The sample space? Yes. Sample space, if I flip 3 times, well, on my 3rd flip, each one of these would have a head and a tail off of it. So your sample space, if you do 3 flips, would be you have head, 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 you have head, head, tail. Well, anyways, let me just tell you, you have 1, 2, 3, 4, 5, 6, 7, 8 different combinations if you wrote them all out, and only one of them is head, head, head. So that's where we come up with the probability of, where'd my thing go? Back here. Okay, that is where my 1/8 probability came from. But if I actually take a coin, let's do it. And I'm going to flip it 8 times, and Lacey's going to tell you how many times we get how many times we get heads. Wait. Well, I guess we could do it till we get a heads. Wait, I have to do 3 coins, don't I can do 3 coins, it'll be the same thing. Only one time in 8 if I flip these 3 coins, so they all end up heads. Let's see what it actually takes here. I think I should have them do it. Oh, let's see. Sam. What is that? No. One was a head, one was a tail. This is going to take forever. But 1 in 8 times it should happen. Ready? I'll let you look at it. All heads? No, that's 2 times. How about that? That's 3 times. There's a tail there. There's 4 times. There's 5 times. Still not. There's 6 times. Still not. Stop that one. That's 2 tails there. That's 7 times. Theoretically, this next time I should get 3 heads. Come on, Ronnie. Get that ball baby up here. We got to get this done before class is over.
Why?
What is this? Oh, that was all tails. 8. There was 9. Experimentally, my probability was 1 in 9. Because when I did the experiment, I got 1 all heads out of the 9 shades there. Now, ladies and gentlemen, what I can tell you is this. And this is why casinos stay in business and why the lottery stays in business and all that. Okay, because they all base their payouts based on experimental. They know all the numbers. Okay? I mean, they do it theoretically. They all know all the numbers and what should happen. Now, experimentally, it's not always going to happen. But I will tell you, if I flipped these coins enough times, these 2 things will always come together. You know what I'm saying? If I flip, that means if I flip 16 times, I should get this to happen twice. If I flip it 24 times, it should happen 3 times. And I can tell you, the more you do the experiment, the closer your experimental will come to theoretical. It's just the way it is. Okay, that's why if a casino opens and somebody wins the jackpot the first day, somebody's probably not going to win it for a long time again. It's just these 2 things, even though they're different at times, if you do the experiment enough times, it's going to end up turning into theoretical. They'll all blend and go together. Good point, sir. All right, for tomorrow, let us do the odds on 32. Odds on 32.